hopefully you have a bunch of didn't get too wet. We'll try to keep things moving along here. It's the after lunch talk slot, so it's always dangerous, but we'll see what we can accomplish with that. So the talk here today is about database scalability patterns. I guess we'll see what that means. We'll get into it, and then I'll explain what that's going to mean. First, a little background, the obligatory background slide. I'm Robert Treat, work for API. We're a consulting company you maybe haven't heard of, but we do like scalability stuff. Work with a lot of different people. I think I personally probably best known for working with Postgres. We use a lot of Postgres in API. I've been using Postgres for a long time. But we also use other stuff, like these things called Oracle MySQL. Probably most of you have heard of these things, maybe even run a few of them. So we do a mix of all three databases. But we also play with other stuff on occasion, right? We'll deal with SQL Server. We'll deal with SQLite. We'll deal with NoSQL. Two of those three things actually are involved with scalability, and the third is not. I will leave it to your imagination to figure out which one. But the point of all that just being that we work with a lot of different databases. And what I've sort of come to realize is as we're working with clients, they usually have a database that they've already picked for better or worse. They come to us and say, hey, we need to get X to Y and make this actually work for a larger number of users. And while I would love to say, like, you can solve your problem easily if you just migrate to a different database, and that answer might be true, nobody actually wants that answer, right? So we end up working with a lot of different systems, doing a lot of different stuff. And in some ways, these systems, they're all based on SQL, and yet not really the same at all, right? When it comes to like the major databases. But what I found is that the patterns that you apply when you're trying to scale systems is actually pretty similar, no matter which database you use, right? And that's sort of where the birth of this talk came out. So, what are database scalability patterns? Sort of a mix of two things, right? It's part design patterns, right? If you think of the classic design patterns of having a singleton or whatever, it's along those lines for a database scalability pattern. There's different ways that people will build architectures around databases in order to handle scalability problems, right? But it's also part application lifecycle. One of the interesting things about scalability patterns in my mind is that somebody else's problem and the patterns they've come up with are not necessarily your problem, right? And trying to use somebody else's pattern to solve your problem might just be like a large waste of time, right? So it's a sort of, it's two parts of that, and understand there's a mix of these things, right? It's not just the patterns, it's when to apply the patterns and how they fit into what you're trying to do. So, put those together, you get database scalability patterns. The first one that we're probably all familiar with, right, is the My First database. It's when you get the cool idea that's going to change the world, and you sit down and you install your database and you write some code and you put it out there and like it only runs on one box, but you're like, hey, check out my new cool thing. This is awesome. It's great. Then somebody actually looks at it and you realize you need to have something a little better than that. Right? So the first sort of pattern is this idea of doing vertical partitioning. Right? And you'll grow the database, and a lot of times people do this, they bought their box, and they got their database running on it. And all database products, or at least the major ones for RDBMSs, they have built-in sort of table partitioning, right? And that idea of either splitting up tables or putting partitions on tables and growing things out that way. And usually you get those features mostly because there's limitations in the way databases work, right? When you have a billion records, it takes a long time to scan them. So if you partition it and then you do your queries just right, you can look at smaller segments of the data and everything's faster, and you can handle more and more traffic, right? Eases maintenance and all that stuff. That's great. It gets you some benefits. It's more to me about performance optimization than it is, really scaling and handling a large load. If you are doing really large, multi-billion row tables, you probably already use this no matter what system that you work on. But by and large, I think it's pretty limited as far as how well you can go, right? You can map out, if you're limited by disk space, like this doesn't help you, right? There are definitely failure scenarios where you will run out of a resource and table partitioning isn't going to get you anywhere there, whether you do it yourself or you have your RDBMS try to do it for you. So the next thing that people look at is the idea of vertical scaling, right? And vertical scaling is basically just the idea that I can buy bigger hardware to solve my problem. I'm not going to spend an overly large amount of time on this one because I think it's sort of, probably looked down upon at this particular conference. The idea of just I'll buy new hardware and solve my problems. But I would say that this is probably the best pattern for most people, right? And probably mostly underrated, right? When you're able to buy new boxes or buy more RAM or buy better disks and solve your problem, more RAM and more disks can be cheap, but it can be a heck of a, or it can be expensive, but it's a heck of a lot cheaper than doing re-engineering of your application, right? I know that there are a lot of people that would say like, well, it's horrible if I have to buy, you know, a half terabyte of RAM and have a huge amount of spindles and all that. But if you compare the cost of that, it's not going to be cheap, but it's probably cheaper than having, you know, 10 developers re-engineer an application for 6 months, right? More importantly, it can help buy you time or buy your way out of problems. So some people make use of this, and you can go pretty far, even, you know, using typical systems these days. You know, terabyte of RAM, you know, 30, 40, 50 spindles or whatever it's going to be, you know, 30 cores in your system. If you're doing that, if you buy that kind of hardware, you can scale on most systems. I would say, you know, you can get like a top 1,000 website with that, right? And I say that based on some of the systems that I've worked on. They can handle that kind of traffic. Now, obviously there's a caveat. With all database things, there's that little it depends, right? It does depend on what you're doing. It does depend on what kind of traffic you need to handle. But generally speaking, this is a good way to solve your problem, right? 37 signals, they do like Basecamp and that kind of thing. They did a blog post a few years back. They said like basically our plan for scaling is to use Moore's law, right? We'll just assume that every couple of years when we start running out of space in our system, we can buy bigger systems, right? And a lot of people sort of laughed at that and said, you know, that's silly, that's not a plan or whatever. But realistically, it could work for them. It worked for a long time. And if that's the way you can scale, and you can do your projections, and you see that that actually works for you, like, I say go for that, right? That is a simple solution. And everything else we're going to talk about is going to be more complicated, right? So don't discount vertical scaling as a scalability solution if it works for you. 99% of the people out there, this will work for them fine. If they're really getting that many sales, they can afford the hardware. They don't need to get something more complicated, right? I'll presume that some of you maybe do need to get something more complicated, right? And that's where we get into talking about things like federated data storage. So the unfortunate part about the database industry is that even when we say something is something, people have different interpretations of that. Like SQL, right? It has a standard, and yet every database implements it differently. So why would we expect any different when it comes to the other terms in our industry? All right, so we've got sharding, we've got read slaves, we've got horizontal partitioning, people are doing maulti-master, you know, master slaves and all this stuff. There's a lot of different terms, and they all kind of mean the same thing. So they all kind of mean the same thing, or at least similar ideas. So the key is sort of like how do you sort of get your head around this, and how do you get a space around it to be able to apply it to your problem. So luckily I'm giving a talk, so I just make up what I think these things should mean, and then I say that. And that works for me, and it probably will work for you as well. I won't say that you can't find a bug, it might call something else, but generally speaking, stick with these terms and then they'll do you well. Right. So the first pattern to talk about when it comes to doing scalability here is doing just sort of that whole read slaves or the master slave pattern, right? This is really good for scaling read list, and it's the one that most people are really familiar with, right? There's been a lot of talk about this, it's been around for a long time. You have the idea of a central database where writes go, right? And that's where all your writes are sent to that system. No matter where the application is talking, all writes go into that system. Those writes are then propagated out to slave machines. Right? Usually this is done by the database itself. It's traditionally been done that way at least. It doesn't have to be. But it's propagated out to the slaves, and then go ahead and you read from the slaves. Right? Nothing really earth-shattering there. It's fairly well known on how to do this, and people have been doing this for a number of years now. I will say that it does kind of depend on the communities you look at how well this is actually done. When you go and look at people that are working in the Oracle community, these terms are actually somewhat foreign to a lot of them, which sounds really bizarre, but they don't do a lot of the sort of master-slave scale-out thing because they can vertically scale their databases so well, right? So they're not really familiar with these terms. It's not that they don't have the technology, they just don't need to use it as much, right? So it's well known, I think, in the web industry where people are using a lot of commodity hardware. You know, they're using, well, I would say older MySQL that really didn't scale very well. Now people are using it, they're going into the cloud where they have hardware issues. So this is not an uncommon pattern. It's fairly well known. The one thing that I like for people to keep in mind, though, is that pattern of slave databases, right? The idea of we have a central write and then read goes someplace else doesn't actually have to be just databases, right? So one of the keys is you can make your application where we write everything everywhere, right? So we have sort of a central canonical data store, but where we write the other data could be something else. It doesn't actually have to be a database, right? When we used to not actually hate NoSQL, we had things like memcache, right? We had things like Lucene or Lucene or Lucene or whichever implementation of that you like, or Sphinx or whatever, right? So we have these sort of non-SQL oriented data stores that people have been using for a number of years to scale systems, right? And they got sort of lost in either, well, it's full text search, so we don't call it a database, or we don't call it data slave, or, it's memcache, it's caching, it's not data storage. But really, it's just data storage with a different format, right? So you can take those kinds of systems and put them out in front of a canonical data store and scale up from there, right? You can even use different types of things for different systems, right? You can have memcache for simple information that you're going to get, right? You can boil down the key value people always want. If you also are going to do full text searching, maybe you put up something like that as well, right? And you have your apps keep track of where all that data is going to go. You can even do, obviously, multiple pattern sets, right? You can have memcache for something, and then you either write to that, then you have a canonical data store, it could be Oracle, and then you have like MySQL databases that you're running out in front of that, where you just only do read access, and you have some process that keeps that data working together. Again, none of this I personally don't find necessarily earth-shattering, but I do think people look at it as a limited scope, right? Not understanding that, and it doesn't just have to be the simple, we do SQL replay, so we write everything here, and the SQL replay goes to these machines, and then I read it with it. There's a lot of different ways you can accomplish that. And it kind of, again, it depends on what you're trying to accomplish overall. Which guarantees and which trade-offs are you willing to make? So, sort of the summary, right? The old sort of way of thinking, the typical is we'll copy the data on each node, right? It's an asynchronous process. It doesn't have to be asynchronous, but if you look at, anyone, I think earlier, right, they were saying if you're not doing it asynchronous, you're doing it wrong. And for distributed computing, well, that's probably true. Right? There are cases where people will try to do it synchronous, and there are places where that's needed. But in a general sense, if you're talking about doing large scale and trying to scale up read operations, you're going to make the trade-off of asynchronous really, really quick. It'll be probably the first thing that you're willing to give up. Right? Just remember, it doesn't have to be that way. Right? You should consider partial copies of data. A lot of systems I've seen, they have a heavy read, but they only need that heavy read on like 2 or 3 tables. So being able to only copy 2 or 3 tables of a database onto another system has an advantage there, right? There might be other activity that's going on, other things is large write operations, but if you don't need to scale the reads, and you're looking to solve a read scaling problem, don't scale that as don't write that data to every place. Just replicate the data you need, and then read from those data stores, right? Think about whether you want it synchronous or how unsynchronous it can be, right? Do you want the app to write it in 2 places? Or do you want the app to put it in a job queue, and then something in the job queue will eventually pick it up and write it in the other place? It depends on how stale that data can be, right? Or don't use an RDBMS for this. I know it's nice to have all your data sort of in the same format, but sometimes it doesn't actually matter. If you're doing complicated tree structures, you actually might want different views of that data, right? You might want a canonical data store in an RDBMS that can store that, and then you have the relationships there. But then if you're going to query really quickly, depending on how often those change, you may want to put that in some other system, right? You might take a NoSQL database that's designed for that and put that out in front so you can query that all the time, even though write changes are made back to your master database and then pushed out to the other systems, right? So you don't have to use an RDBMS for that. It's just the typical way that it's always been done. One thing to remember though, is before you get into this, right, if you've gone from I have a large database and I'm still running out of memory or CPU or IO or whatever it is, and I need to scale my reload, dumping out additional slaves will require application changes. Right? Simple one would be you need to realize that now that your data can be stale and it doesn't necessarily, it's not always going to be correct, how are you going to handle that situation? Right? And those changes have to be done in the application side. It's not something the database can do for you. So before you go buy those servers, make sure you have buy-in on the development side to say, hey, we're going to put these servers out, Your code needs to be smart enough, and we need to look for those edge cases where if you go and write data and then you read it from a slave and it's not what you just wrote, how big of a problem is that? It probably is a problem. So are there tricks that you can do to get around it? Maybe when I write, I should just go back and read on that same connection. And then when I come back some other day, I'll go to the read slave. Right? I mean, there's different tricks you can play there depending on how important that is. But it will require application changes. You'll have to go change your code to see how that's going to work. The other thing about all this is, when I look at it, I say, this is actually the easy stuff. Okay? Being able to scale preload, like I said, it's been done for probably half a dozen years in fairly widespread discussion. People, like I said, I think do narrowly look at it a lot of times, but by and large, if you study the sort of web industry and how it's working, this was the first problem that people really had, was scaling a large number of read operations. And so this has been sort of a well-worn path. There's new technologies that are coming up, so you should look at those and figure out how they apply. But this is all quote-unquote the easy stuff, right? People probably have an idea if you say master-slave, what that means. Developers probably understand what that means, and they can wrap their head around this data over here is going to be like 3 seconds out of date from this data over here that you just wrote. Those people are okay with that. Problem is, that doesn't solve every problem, right? Master-slave works good for scaling reads, but doesn't really work at all for scaling writes. And today, in the world that we live in, scaling writes is becoming more and more of a problem. And it isn't actually so much that people's businesses are changing. I think they're just deciding, we should collect more information in general, right? If we have a service where, we have a user community using our site, but to do sort of group features, they're using Yahoo, and when they send email, they're using, Gmail to send that back and forth, and when they do messaging and they want to be noticed, they use Twitter for that. There's a lot of knowledge there that your company may not understand, may not see at all, right? They have nobody to collect that information, or the ways are very poor. So a lot of companies are saying, we should provide our own messaging system internally, right? We should have something where when you send an email, it actually, don't send an email directly to an address. Send it through an alias if you provide your username at mycompany.com, right? So then we can trap that and we can see what kind of conversation is going on. Your core business may not have changed at all, but suddenly you have a very different look at what kind of data you need to capture, right? And your problem with maybe scaling reads to be able to handle the traffic you have becomes a write scale problem. Because now you're trying to capture all this other additional information, and now you need a lot of different I/O constraints than you had previously. So that's where scaling writes comes. This is not easy, right? Unfortunately. It's not the same problem as scaling reads, right? So that's why master-slave doesn't really apply. People like to think that multi-master is the way you solve this problem. The problem is it doesn't really work for a write scale situation, right? A lot of people have tried to set up a multi-master system, right? I would say if you look at most of the open source ones, anyone that actually works even remotely in production has a number of constraints, like everything has to fit in memory, right? Or something along those lines. Now, luckily, memory is getting cheap, so you can actually start to get pretty big in that constraint, but it's still a pretty hefty constraint that not a lot of people can deal with. So there's a lot of different ways to try to implement this, and there are a number of failed projects along the way that if you go back and look, you can see where people got bogged down in different areas of trying to implement this as a general purpose solution. A few of those really work in production. I would guess that if you go look at all the talks that you're going to see here today, very few of those are talking about multi-master replication, right? So it's not the common way to do it because it doesn't really work that well. The theory being, you write to any node, and the database will sync the data across, right? So that should cut down. And I guess I tend to make fun of business people, but a lot of technologists actually have the same wrong mentality here, which is I had one server and I could do, 100,000 writes, and that was great. And so when I get a second server, I should be able to do 200,000 writes, because I'm just doing twice as much. But what they forget is, in multi-master, both nodes are supposed to have all the data, right? So instantly this starts to fall apart, because when you write to one, it still has the right data to the other one, so then it knows what's going on. Right? So you're not scaling your write situation at all. It can help in some situations. If you have like a CPU-based workload, and that's your bottleneck, then actually doing multi-master could be helpful, right? So I don't want to totally discount multi-master as a scaling solution, because there are situations where if it's complex to write the data onto a node, right? But once you've written it, it's very easy to transfer and move that data off to the other one. Then you reduce the CPU overhead, and you can buy yourself some scalability. The problem is that usually only works up to like 2 nodes, right? right? By the time you get to node number 3, you now have enough sort of network overhead or communications overhead between the different nodes that you start to lose that benefit as well, right? So there are very few, and certainly none that aren't fairly expensive, systems out there that will allow you to try to do multiple nodes beyond 2. Even if you look at, like I think MySQL has sort of, they call it triple M replication setup, right? But if you actually look at how the data is moved around, it's not really, 3 different masters, right? It's more like a multi-master with like a ready to failover slave there, right? So sort of don't be bought into that idea that that'll get you out of your problems. Probably not going to. It does work well as a failover solution if you're doing multi-master, and this is where I've seen it used pretty commonly, and that's okay. It's just not so great as a scalability solution, right? So, and remember, those are 2 sort of totally different problems. A lot of people that are talking about scalability, right, the sort of industry mantra is that that means availability at all times, right? But solving a failover problem and solving a scaling problem are 2 different things. Failover is easily solved. That's the most easy problem. It's been solved for years in every product that you buy, right? Basically, like we have a copy here, and you flip a switch, and now you run this copy over here. And that's simple, but that's not scaling, right? That just means I have 1 instance, and I've used 2 to keep that going. I'm juggling the balls in the air, right? When you're doing failover, it's a totally different thing. Multi-master can work for that, right? So again, I don't want to totally discount. It's not to say that the industry doesn't have need for it, but it's not going to work as a scalability solution. So then you get to looking at sort of the 2 more buzzwordy type things, part of this falls under horizontal partition, right? And people sort of describe this as 2 different things. Half the people say, well, this is sharding, right? This is the industry buzzword of the day, which is sharding. I think the other half sort of lists this as SOA, right? Sort of services-oriented architecture. And the sort of 30-second loose, like, it's not really this, but let's call it this, is we take the data and we split it up, and we run it on multiple machines, and we don't have all the data everywhere, and you just query where you need to query, right? And both of these sort of fit into that really loose, interpretation. And this is like, I would say it's a devil in the details kind of thing, except we're so ambiguous at this point that we haven't even come close to the details, and you will quickly find the devil in a lot of these things, right? To me, horizontal partitioning is not sharding, right? When I look at it, when I define the term, and again, bonus points because I'm doing the talk. So when I define the term, I look at more as it's an SOA type of thing, right? If you're going to do horizontal partitioning. There are problems that it will solve and that it will do okay with, but understanding that, at least for now, we're going to focus on the SOA aspect of that. So what does that mean? When I say SOA, like, I've actually grown accustomed to using that acronym, which is really odd, because 10 years ago, when I heard people say the acronym, I was like, that's the stupidest thing I've ever heard, right? So I'm either getting older and more soup-like, but I'm hoping that's not the case, or at least now I sort of understand maybe a way that it could work, right? So when I look at horizontal partitioning, what I'm going with is, we're going to take our schema, right? And I'm coming from the traditional sort of relational database idea that we have a bunch of tables, right? We throw a lot of data in there. So we're going to take that schema and divide it up by job operation, right? We'll move each piece out into its own server. And we'll duplicate some of the data that we need to duplicate, right? So if you take like a traditional system, right? So everybody probably has users, or I guess you probably wouldn't be here. You might have like some simple thing like a forums, right, for users to communicate. And maybe your users revolve around items of some type, right? So whatever you're doing with that, you've got those 3 things. And you can look at your database and decide like, well, forum software, might be third party, and you may have installed it in your primary database to get it started. And because you wanted to integrate it with like your login system or something like that, so you wanted it to have access to your user data. Well, that's usually like an easy thing to break out, right? The code is usually fairly separate. It's not too well tied, so you just take all the forum stuff and you stick it in another database someplace. You got to duplicate a little bit of data, right? Because you still need access to the user information. So how much of that you need to do depends on how tightly integrated you've made those things. If you've made your login infrastructure work, you may decide like the answer is take the usernames and passwords and put them both in the user's database and in the forum software. So when people go and hit the forums, they can log in on the forums database and they don't have to look at anything else, right? That's one way to do it, not the only way. But the idea is that you're going to take that forums, all those tables and all that data, stick it someplace else. You'll do the same thing with items. Whatever the service is that is dealing with the items, take that data, put it someplace else, take your user information, manage that in its own database, and then sort of grow those systems up. Now, the most important thing when talking about this, and before I go any further, this is like what I have to say because it infuriates me when this doesn't happen, is that if you're going to do this, you have to separate the dependencies in the app code first, right? This is the first mistake that I see people make when they're starting to do this, and so there you go. See, everybody's train of thought, I get so mad just thinking about it, right? I've been bitten by this enough times, and my problem is I generally work as a DBA, right? So I'm not the guy who's supposed to go and change the app code to make this work. So I see people doing this, and what I mean by separating those dependencies are, take a simple site. So we could go with our users in our forums, right? Let's say every time you log into your site, you've decided if somebody has posted a new item to the thread that you started, we're going to put a little flag on your top nav bar, right? And so people write up the code, and at one point all this data was in the same database, so that was really easy, right? It was like two queries, one for the user information and one over to the table of the forum. Now it's a whole separate machine, right? And when the day that this happens to you, you too will get infuriated, right? The forum system will crash. Someone will go to log in, and the call to try to go over to the forums database to see how if you had a new post on your thread will cause an error, which will cause the page not to load, which means your site's down, right? What you've actually done is you've introduced another point of failure in your system, right? You haven't decoupled that in your application. So this is the first thing that needs to go. Look, make the developers do this before you actually put that other system on, right? Because there's no reason you can't decouple it in the app code before you actually put the databases out there, right? If you try to go look up forums and for some reason you don't get an answer back, load without it, right? It's not a crazy idea. The other thing to remember here is that each new node is an instance of vertical scaling, right? If you separate out, and I love picking on forums because, I mean, I've seen the crappy state of like open source forums implementation. If you actually have a forums implementation and you build that and you put it in a database, like nobody ever wants to go work on that code, right? Like it is what it is. And so as you're trying to scale your site up, if you're able to project out your forums traffic and decide like, you know what, for these other parts we're going to have to do something interesting, we'll have to do a lot of optimization and that kind of stuff. But for the forums thing, we don't even want people to learn that code, right? It's that bad. So if we have a developer go work on that first, they'll be dumber and won't be able to understand the rest of our site. So just leave the forum stuff by itself. When we project, 2 years from now, when that's not going to handle it on that server, we'll just buy a new server for forums. And that way people don't have to deal with it. Let it run its own thing. It is a service, and it can do its own piece, and it doesn't have to really be dependent on the other pieces of the site. And we'll spend our time, we'll spend our energy on core functionality around the items and the users that are coming to our site, right? So remember, separate the dependencies in the app code. That's like the key thing. Do that before you pull up the second server, right? And then remember that each new node has its own sort of path it can take. It can do vertical scaling. You can do partitioning in those systems, or you can even break these down even further, right? So you think like the user's information. So part of that might have been usernames and passwords. If the user starts to grow so big that as you watch the life cycle there, first you partition it, you split your table into sections based on the states or whatever, and then you might decide, you know what we really could use is if we split out like that login functionality, because everybody actually needs that. So let's just take the login functionality and make that its own service, right? And we'll just put the usernames and passwords, and we'll do just that piece of management, and we can keep that in a database that does its own thing. And we know that's the most heavily hit piece of this, because people change their passwords regularly enough, or we get new signups, but addresses maybe not so much, right? Like it's not that, people don't need to see what their address is all the time. Maybe when they buy something, or if they're getting something shipped to them, logins they have to do every day, right? So you can even take these further and figure out what are the job operations on these individual nodes as you're going down the line, split those out and make those into their own system. All of that is horizontal partitioning, right? I don't want to ignore horizontal scaling, right? It's a different thing, right? This is where we go with the sort of shard idea. And it is also useful, but it is a different piece. So the first thing that when you start thinking about horizontal scaling, right, is the way that most of this works is you take your data and you split it across servers based on some algorithm, right? And the algorithm doesn't have to be very difficult, right? And by difficult, I say you could use something like, mod 3, and you're going to have 3 servers, and everyone says, well, that's simple. That actually can become very complicated, so it doesn't even have to be that difficult, right? It could just be like, I'm going to make buckets, and then as we go along, if it's Monday, throw it over here, if it's Tuesday, over here, and whatever that code is easily changed so that I can, say if it's 12 p.m., throw it in that other bucket. right? You just need some type of algorithm. Understand you have some system that's going to decide where data really goes in the system, right? Once you figure out where it's supposed to go, you drop it into multiple buckets, right? Presumably multiple buckets. So here's sort of a typical look at what that would be, right? You have your application. Instead of where it used to talk to a database to get information, it actually now talks to something, right, which can be another database that does the magic hash algorithm thing that tells you which other database you've got to put the data into, right? And when you want to read data, you query the first database and say, hey, I need this piece of data, and it says, go get the data from this other data source, right? And then your out goes and queries the other data source. Now the funny part is this actually looks a lot like doing master-slave in a lot of ways, right? It's not actually horribly different. If you build code along those lines and you've done the right things, you can actually switch into these patterns, and it's not like a total mind shift. You need to understand the differences, but more or less you'll be able to do that. Again, the hash algorithm thing, like, don't think it has to be fancy. Just understand you need something to tell you where it's supposed to go. I guess I was also say that there's different ways to implement this. How you want to do that. How much knowledge do you want the app to have, right? You could just have the app know the magic hash algorithm, right? That's one way to do it. So rather than say I'm going to ask someone, I'll just know if you're doing something like a mod 3, right? I guess the app code could probably handle that complexity, and just say like, well, if it's this, then I know it's over in that data bucket. If it's that one, it goes over here, and I read and write to those individually. There are sort of commercial solutions that will give you this type of thing. For example, like I don't know if you guys have heard of like Ask Your Data. It basically gives a proxy system that sits in the middle of your app and your data store, and you ask it questions, and it says this is where the data goes, and this is where you get it from, right? If you look at most of the NoSQL implementations that I've seen, I should say that. So some of them are more like the app is going to know, and then I just query whatever my data storage system is, and it figures it out and it tells me. Other ones are more, I have a proxy sitting in the middle, right? And how you do that doesn't really matter so much, right? You can go back and forth between these two ideas, and that's cool. It's just understanding that multiple data stores, your app needs to understand, that it's not going to have just one connection to one data source, right? You got to be able to handle multiple connections. Normally that overhead, I know people get concerned about that. That overhead usually isn't all that bad, right? If you're already doing connection pooling, having 2 connections open probably isn't crazy. If you've done sort of the scale out of read databases with master-slave, then you probably, or you at least hopefully have already determined, like, I've got writes going here, reads going here, so I've got 2 connections anyways. This isn't all that different, right? I need one connection for talking to the mapping system, and then another one to go to the other database. Okay. So be careful as you're setting this up. I mean, I would definitely say if you're trying to write this, the scary part about your app knowing the knowledge is that you need to understand the impact of having different algorithms, right, and how that works. My advice is always make it as simple and flexible as possible. And simple doesn't mean using math, right? Like, that's a nice way to do it, but, so I'll give you an example, right? You go to the mod 3 idea where you have 3 buckets, and so you've got your data split all over all 3 of those. And when you want to switch to like mod 4, right, or go to mod 10 or whatever that's going to be, and have that many more buckets, the problem is now you have to like rebalance those data sources, right? There's data that is in one storage node that now really should be moved to another one. And so when are you going to flip that switch where you're going to have massive data rewriting going on in your data layer, right? And probably your 3 buckets that you already had are already overfilling, right? Which is why you decided you needed more buckets. So be careful with that kind of thing. I much prefer sort of a loosey-goosey, like, I'll just say where data is going to go, and it's not based on any kind of map in particular. And I'll turn those on and off if I can, and it's completely arbitrary, but I'm paying enough attention that I'll make sure I don't like hurt myself too bad. So it is key that someone keeps track of that data, right? And someone provides multiple services. Just depends on where you want to do it. So boiling all of that stuff down, right? And in theory, like when you make a talk called Database Scalability Patterns, people want to find some universal truth. And databases, everything is it depends. So it's kind of a hard match to get those 2 together, right? So I've boiled in a couple that I think maybe potentially these are universal truths. I think they do actually apply no matter which pattern you're using and how you're trying to apply it. These things probably do make sense, right? Vertical scalability It's helpful for every pattern, right? And what I mean by that is that the more efficient any individual node can be, the better off you're going to be, right? Whether you're doing full horizontal scaling and all your individual nodes are taking like one slice of the data, and you've decided like, well, I don't really need great performance because I can always spin up other nodes, the better those individual nodes can perform, the fewer nodes you need overall, right? So being able to scale those up is always good. If you find yourself in an issue where, you've got to rebalance trees or something on the data storage side, being able to say, you know what, if I just put more RAM in that machine, it'll give me enough extra power to go ahead and rebalance the trees, that's handy, right? So vertical scalability always helpful no matter which pattern you're trying to use. So another one that I think is important to realize, and I think this point is going to get hammered home as you go through the talks today, is that new nodes are never free, right? The thing that I really like about vertical scaling, and why I say people should try to stick to it if they can, is that it's pretty simple for people to wrap their mind around the concept of an application talking to a database, right? When all your database is there, you do actually get the idea of like having a global state. You can query something and know that that data is the data that you want. When you start to do distributed computing and starting to move your data around, like all of that is going to have a cost, right? And it's cost at multiple layers of the operation, right? Every new server that you spin up is a new server that can crash. So you need to have some kind of failover plan for all those things, right? Just because you can put the data in 10 buckets, if you haven't worked out an algorithm where data is written into 2 different buckets, if one of those buckets goes down, you need to have some kind of backup plan. Even losing 1/10 of all of your user, information can be kind of devastating, right? It's better than losing it all. I'll grant you that, right? 100% loss is, a little bit worse than 10% loss. The 10% loss is actually still pretty bad, right? If your bank came to you and said, well, we lost 10% of our customers' data, and 10% of the money is gone, but luckily you're not in that 10%. We still have your money. We still know what bills you're going to have to pay. How long are you going to keep your money in that bank, right? You're probably going to want to move it out pretty quick. So new node is never free, right? There's also added management costs, right? As you make the architecture more complex, you've got to understand that people ramping up, people that are trying to work on these systems, need to be taught, and it has to be explained how you're going to actually deal with that operationally, right? Some of the more complex systems that we work on ECI, we're lucky we have like these whiteboard walls, and we go in and we'll have a conversation, and we'll leave that diagram up on the wall for like 6 months. If it's complex enough, we know that when we're going to have a conversation about something, we're going to talk about a failure condition, we still need the picture there, right? We can't actually picture 20 different servers that are talking in different ways to each other. It's too hard to think about that all the time, right? If you're moving from project to project and you haven't had to deal with it for a month, and then you come back to it, you need the picture to visualize it. So you've got to have that kind of stuff, right? And make that available and understand that complexity means you need to be more visible. People are going to have to get more up to speed on those things, right? And like I said, it's also going to add complexity to your app code. It's very easy to have one connection that says, go get data, go write data, right? That's easy. We can all do that. I can do that, not even a real developer. So having, multiple data stores, having reads and writes, whatever version of that you're trying to apply is going to add complexity to your app code. So I mentioned the life cycle earlier, right? And this is sort of the recap of life cycle, right? How does this all fit together, right? We all start with my first DB. We move into vertical partitioning, right? Which is doing like table level partitioning inside the database. I think most people can actually probably skip that, right? What I found is I get a lot of people asking me like, hey, we should partition these tables, right? Like that's the solution to our problem. And in a lot of cases, it really isn't. You can look at the way you're querying against the table and determine, you know what, there's no great partition key. Even if there's a good partition key for this query, you run this query, 30% of the time. This other query will need to go across those partitions. You run that 30% of the time, and then you got another 40% hazy mix, right? You don't have a good partition key. So it can help some scenarios, but it doesn't help everybody, right? So a lot of times people skip right past that. But you'll get into vertical scaling, right? Probably, at some point you'll be working on hardware and realize that if the hardware is 3 to 5 years old, especially when you get towards the 5, like you can get phenomenally better hardware for a pretty low cost compared to whatever you bought 5 years ago, right? And it's pretty easy to stand up new hardware. When it comes to databases, pretty sure every database solution has some kind of easy flip over, fail over solution to get from one box to another, right? You got a couple terabytes of data, it might take a while, but the actual flip itself should be pretty quick and painless. Right, so getting onto the new hardware usually is not a showstopper, and you can scale up that way. Eventually that might start to run out, and that's not going to work for you either. Right, so you move on to read slaves. Again, it depends, because you've got to have read traffic to make this decision. Right, and some people won't actually have enough of an overbalance of read traffic. They will have enough write traffic. They have to move on to something else right away. And most people will then tend to move into horizontal partition. Right, take the unimportant pieces, move it to its own service, and let it run and do its thing. You'll notice I did actually leave out horizontal scaling here. Right, doing sort of the sharded multi-bucket, mapping system. It's sort of great, and you can put it in, into your project any place you want. But it's not really a lifecycle thing, right? Once you decide to go to that, you're going to probably rewrite a lot of your app. You're going to add a lot of complexity. You're going to have developers quit because they don't want to deal with it. You're going to hire new people, that hopefully are smarter. I would say, try to put that off if you can. But when you're ready to do it, take the plunge. But you probably have looked at these other solutions first, and for some reason figured out why it's not going to apply to you. So a couple of quick tips, right? Just to sort of re-stress some things. Plan for layered data sources, right? This is not a foreign concept now, like I said. Right? People are pretty comfortable with the understanding of memcache in front of a database, right? That I will look in one place for data, and if it's not there, I'll go look over in the database for that. So plan for that right off the bat, right? There's no reason not to sort of think about that as you're doing an application. Have read and write connections in the code. This one I think is like a fundamentally important thing that nobody really tends to think about or care about. And that's knowing when your application is reading data and when it is writing data. Because those are like fundamentally different problems. No matter what type of scaling pattern you're trying to do, no matter what your business is, when you read data for something, someplace that means something, right, different than if you're going to write data. So understand that in your code and make sure your application can tell the difference. Whether you end up having to read slaves or you do multiple buckets or whatever, knowing this piece of information ahead of time is going to be huge. Right? I have seen sort of, system migration implementation stop because they realized I would have to go back and look at every single database connection call and look at the SQL that has been written there and figure out if it's a read or a write. And if you use like database functions, that can actually be even more complicated, right? So I can't even look at the code. I gotta look at the code to see what the function is, and then go look what function it calls, right? So have that knowledge ahead of time when you are writing an application. Say, hey, I'm reading data only, or I'm going to start writing some data. I'd also recommend if you're using the database that supports this. So I guess if you're, so for like Postgres and Oracle has this notion of schemas. MySQL sort of bastardized this, so it's probably more like databases instead of schemas. But use schemas to separate out services, right? If you're going to install foreign software in your main database, because you just need something up really quick, like don't pollute the namespace of having all those foreign tables intermingled with the rest of them. Try to stick that in a separate schema so that you easily know at some point if I have to move this out, I can take the foreign stuff that's all in that one schema and move it out. You can look at like foreign key constraints that you have going across tables, or look at SQL that's joining across schemas, and immediately understand where are your constraints as far as pulling data out of the system and putting it in another one. Right? So it's really huge. If you can separate that out at the logical level when you're designing things to begin with, being able to go back and rewire and retrofit, right, will be much, much easier. That's all I got. So open for questions, otherwise more. My blog is zilla.net. I'll post the slides there. I'm pretty sure they'll be on the search page at Route 2. Hopefully everybody figured that one out. So, any questions? Yep.
On vertical scalability, are you finding that SSDs are obsoleting some of the multi-tiering? So it's fast enough you can just get rid of the memcache?
No. So it's not. I think it will end up that way. Maybe. I don't know. But we haven't seen that.
Basically, let Moore's law solve more problems.
Yeah, I mean that's the idea, right? So I think that's why I say like philosophically or academically that will eventually be the case. In the testing we've done, there's a combination of SSD equipment is either too crappily manufactured or it's manufactured specifically for heavy read or heavy write activity. But doing concurrent read writes is not like a forte of SSDs, and it's something that most database systems tend to need to have to do. Right? If you could take a system and if you're doing separate your reading logs onto SSDs or like X logs or whatever, put some heavy write portion onto an SSD. We've seen big, benefits of that. But as a general, like it's replacing everything, I'm yet to be convinced of that. So I do have a project coming up that's the plan. So we're going to see. But so far, I wouldn't say that would do it.